Hi Year 11, it's Mr. Green here. I'm going to be taking you through this chemistry lesson to know how potable water is obtained from seawater. We have 3 success criteria for this lesson: to be able to describe the process of desalination of seawater by distillation, to describe the process of desalination by reverse osmosis, and evaluate advantages and disadvantages of obtaining potable water from seawater. Our first task today is the retrieval practice, so I'll put that up on there. If you'd like to pause the video while you attempt those 3 questions, restart the video once you have finished them. Okay, question 1 then. What's meant by pure water? Pure water is water with only water and nothing else. It only contains water molecules in there, nothing dissolved in there, no other materials. So what do we call water that is suitable to drink? Well, water that's suitable to drink is referred to as potable water. 3 sources we can use to obtain this type of drinking water. So the 3 sources we can use are fresh water from rivers, lakes, seawater, which is salty water from the sea, and wastewater that humans produce as a result of living. Draw the structural formula for the first 4 alkanes and write their molecular formula. So the first 4 alkanes are as follows: methane, ethane, propane, and butane. Remember, they are alkanes, so they only contain single bonds. Underneath, you write the molecular formula. So methane would be CH4, ethane CH2, propane C3H8, and butane C4H10. There's a pattern there. What you do for alkanes is you double the number of carbons and add 2 to get the number of hydrogens. So for propane, we've got 3 carbon atoms, double 3 is 6, add 2 means we've got 8 hydrogen atoms. Okay, so today we're going to be looking at how potable water is obtained from seawater. There's our 3 success criteria which I went through previously. So why don't we class bottled water as pure water? Well, bottled water contains lots of dissolved substances like minerals and salts and other materials. Doesn't mean they're not safe to drink. They are safe to drink because it is free from any harmful substances, anything that could cause humans harm or illness. So if we have potable water, it doesn't mean it's completely pure. It means there are materials present in there. Potable water is water that is safe to drink. So where can we get these from? We have 3 sources: fresh water from rivers, lakes and reservoirs, wastewater from human waste, and seawater, which is really salty. So to obtain potable water, we've got to treat these sources. Today we're going to look at getting potable water from seawater. Okay, the difference between fresh water and seawater. Pause the video whilst you write down some differences. Okay, seawater has got lots of salt dissolved in the water, whereas fresh water doesn't have any salt dissolved in there. Doesn't mean fresh water is pure and contains no materials. It will contain dissolved materials, but one of those will not be salt. So seawater treatment process, we contain lots of dissolved salt deposits like sodium chloride. We would have to do this in countries that have got very little fresh water, so not many rivers, not many lakes. So places like Kuwait, they would do this process which is referred to as desalination. Desalination is removing the salt from the water. And there are 2 processes that you need to know. The first one is distillation, and the second one is a process that uses a membrane referred to as reverse osmosis. We're going to look at both those in detail. So first up, distillation. In distillation, water is evaporated to make steam. The steam is then condensed to produce liquid water, and all the salt is left behind in the flask. This works because there are differing boiling points and melting points of water and salt. Initially, we start with the salt water at the bottom here. We'd heat that, and when it gets to 100 degrees, the water would boil off, but the salt would remain behind. So the water turns into steam and carries on up this tube. The steam is diverted down this tube into what's called the condenser, and around the condenser we have a jacket which contains cold water which surrounds that condenser. The temperature of the steam then drops. It turns from steam into liquid water and then drops down into here where we have pure water for use. So we've removed the salt from that water and given us pure water to use. Now, distillation of seawater we can do in the lab, and we can use the apparatus that you can see there. We make sure the conical flask is held on the tripod and gauze using a clamp stand and put a mixture of ice and water in the beaker that surrounds that test tube. So that's this one here. We heat the seawater with the Bunsen burner, which starts to boil, and then we reduce the heat so the water boils quite gently. Distilled water will collect in this test tube. You need to know how to do this for part of your required practical, so please review what's happening there, look at distillation, look at that setup, and make sure you've got the details on there. Quick task, if you could pause the video and try and label each part of that apparatus, so A, B, C, D, E and F, with the labels on the right hand side. Okay, here's your labels. So, A was the Bunsen burner, B was the conical flask, C was the bung, D was the delivery tube, E was the boiling tube, and finally F was the beaker containing a mixture of ice and water. If we set that up correctly and we boil that salty water, we will eventually get pure water collecting in the boiling tube. Okay, so 4 questions on distillation. If you pause the video whilst you attempt those questions, and when you're ready for those answers, please unpause the video. Okay, so question 1. What's meant by desalination? Well, desalination is the removal of salts from a substance. Question 2. Why is obtaining potable water from seawater desalination? We're removing the salt from seawater in order to get water to drink. Desalination is the removal from salt from a substance, so removing salt from seawater would also be referred to as desalination. What are those 2 methods? 2 methods that we've briefly discussed. We've discussed one in detail, one slightly less detail, which we'll go into next. That would be distillation and reverse osmosis. And 4, how does distillation of seawater produce potable water? Seawater is heated to the boiling point of water. The water evaporates and turns into steam, and the steam is then cooled and condenses back into liquid water, which can be collected and then drank. The salt from the seawater is left behind in the flask. Please pause the video to ensure you've got those full answers on there and you can refer back to them. Okay, so we've done our seawater by distillation. Our next step is to look at reverse osmosis. So, reverse osmosis, you can see the 2 diagrams on the side there. Seawater is forced through a membrane at really, really high pressure. So we push the seawater through this really, really thin membrane. The membrane sheets are designed so they catch salt ions. So, the salty water is pushed through the membrane. When it emerges on the other side of the membrane, there's no salt in there. The salt remains on that membrane, so it's removed from the water. And this process produces clean water. The reason we can do this is because water molecules are small enough to fit through the holes in the membrane, whereas large particles like sodium and chloride ions, which make up salt, cannot fit through. So we'd start out with salty water, push it through the membrane, the salt gets trapped in the membrane, the water continues through, we then have cleaner water. So, review questions on this one. Pause the video again while you answer all these and restart it when you want me to go through the answers. Okay, so question 1. What's used to filter out the salt from seawater in reverse osmosis? In this case, we would use what's called a partially permeable membrane. Permeable means things can pass through there. Partially means some things pass through, some things get trapped. The partially permeable membrane we'll use in reverse osmosis will trap the salt but allow the water to go through. Fill in the missing words to explain how reverse osmosis separates the ions. Well, seawater passes through a membrane at high pressure. The water can pass through the membrane because water molecules are small enough to pass through the holes in the membrane, whilst chloride and sodium ions are too big to pass through. Why do we call this reverse osmosis? In osmosis, normal osmosis, water moves from a place of dilute ions, which is lots of water, to a place with a high concentration of ions, where there's a smaller amount of water. In reverse osmosis, the water is moving from a high concentration of ions to where there's no ions. So this is against the concentration gradient. That's why we have to apply pressure and put energy in there to force that through so that the salt stays behind on the membrane and the water passes through. Okay, we've been through reverse osmosis. We're going to look at advantages and disadvantages now. So, two big disadvantages of treating seawater. Number one, it is really expensive. We have to use energy for both those processes. Distillation requires heat and reverse osmosis uses high pressures, in some cases very high pressures. In order to get that, we have to use energy, and we have to get energy from different sources, so we have to buy the fuel to get that energy, and then that becomes expensive. Our second issue is it's not practical for large quantities of water. We can only do it in small amounts at a time. So we can do that often and often enough that we'll get enough water, but if we want a large amount of water very, very quickly, reverse osmosis and distillation are not suitable to use for that. Why do we not use desalination to make our potable water, but countries like Kuwait are forced to use these methods? Pause the video while you answer that question. Okay, the reason why that is in England we've got lots of freshwater sources because we get lots of rain. We do have a lot of seawater around our country, but the process is so expensive and difficult we don't bother doing it in large enough quantities. Now in Kuwait the annual rainfall is 110 millimetres per year and freshwater streams don't exist. So they have no freshwater sources generally to get to. Their only source of water would be seawater, so almost 90% of their potable water is satisfied by seawater desalination, and they would use both those methods to produce that. Okay, quickly, if we can try and define these key terms. So you've got the definition there. At the top, you've got the key terms. If you could match the right term up with the right definition, write those down, pause the video while you do so. Okay, so water that's made safe to drink is potable water. Water that contains only only water molecules is pure water. I gave that away. The process of evaporation followed by condensation is distillation. The removal of sodium and chloride ions from water, that's desalination. And the process used to filter seawater using a membrane, that's reverse osmosis. Okay, we've been through all three success criteria on there. I hope you found that useful. If you want to go through anything again, please restart the video, go through again and see if you can get all the materials you can from there. Hope it's been useful and I'll see you again soon. Goodbye.